Hi, my name's Sam Abrams, and here are my responses for task 5.7. For the first question, what does the CRISP DM methodology for data mining entail? What does the data analyst do in each step? There are 6 steps to the CRISP DM model, which is a standardized methodology to planning data mining projects. The first 2 steps are business understanding and data understanding. The first step, business understanding, is important to determine what the objectives of the project are. What are we trying to accomplish? How do we measure success in this project? Who's responsible for what? What data will be important? That kind of thing, just to make sure that stakeholder and analyst are very on the same page for the project. The second tenet, data understanding, refers to collecting data, describing data, and exploring data. It's kind of the introductory exploratory phase to see what you have, what you might need to make, because the next step, data preparation, is where you are narrowing down what data you're going to use, cleaning that data, and then maybe constructing new data, integrating some data sources, formatting your data, changing the data types, that kind of thing. In order to, step 4, make a model. It's important here to select what modeling technique you want to use, which would be dependent on the project. If regression, classification, that sort of thing. It's also a good time to decide whether you want to make a training set, test set, and a validation set, kind of how you want to distribute your data that way. Once the model is generated, next comes step 5, which is evaluation. Here's where you evaluate the results of your test group, review the process, look for any holes, and then determine what the next steps will be. Finally, once all the boxes are checked, deployment is the final step. Here's where you roll out the final project, you produce your final report, and then, if desired, host a postmortem and see what went well, what went wrong, and just kind of review the project from 30,000 feet. Now, for the second question about forecasting time series and what does the time series analysis involve? Time series analysis involves comparing 2 variables, where one of the variables is time. 3 descriptors of a time series analysis that you want to take note of. One is stationarity, refers to the trend or lack thereof in a time series. Time series with high stationarity will have a constant mean and variance over time. There will obviously be peaks and valleys, but over a longer length of time, you'll have a consistent mean and consistent variance there. Second descriptor is autocorrelation. Autocorrelation refers to it happens when data points fluctuate based on repeated patterns. So energy usage during a day, sunscreen sales during the summer, traffic during rush hour. There's going to be patterns to those trends. So as time goes, you'll see kind of a predicted, rise, fall, or whatever the case may be. Final descriptor is seasonality. Seasonality refers to fluctuations at periodic levels. Similar to autocorrelation, except seasonality is very specific. Hence the name seasonality kind of comes along just like fall does every year. Christmas sales would be a great example of this. That sales are going to spike for ornaments, Christmas trees, that kind of thing. And November and December, so seasonality. As for forecasting requires a stationary time series. So you're going to forecast data, you have to transform the data, from stationary to non-stationary. A couple of ways to do this. Moving average kind of smooths out the time series and gets rid of the noise that exists. Exponential smoothing is similar to that, but it kind of gives a greater importance to recent observations and lesser importance to older. And those factors depend on whatever the project needs. ARIMA is a good option whenever there's both trends and seasonality, but again requires stationary to do so. ARIMA is a combination of autoregressive modeling and moving average. So it's able to analyze both appearance and seasonality fairly well. For the third question, discuss the main principles of data ethics. Data ethics refers to collecting, using, and sharing data responsibly, fairly, transparently, and privately. The goal is to avoid bias in data collection and in analysis, to protect customers' sensitive information, and to be open with consumers about how the data will be used and also protected. Companies can uphold these principles by weaving the concepts above into their business model, right? Only collect data that's necessary, make your privacy policies very easy, very accessible on your website and available. Make sure the users are well informed regarding how their data is going to be collected and used and protected. Question 4. Imagine you're an analyst at a financial services company and you have some concerns about bias in a way that predictive model was measured. I would first, if I wanted to raise my concerns to my manager or supervisor, I would first gather examples that support that. So like where in the data, excuse me, where in the data do we feel like, we have some gaps or some cases of bias. Once I kind of have all the examples gathered, schedule a meeting with my supervisor and to kind of lay out objectively and clearly what I believe the issues are. I would also bring solutions that could mitigate that bias, so that we're not just pointing out problems without solutions. To avoid measurement bias, in the first place, it's important to define the process by which data will be collected and used, and make sure that all parties are on the same page with that. Potential sources of bias need to be addressed early to make sure that everyone involved with a project can avoid any sort of subjective interpretation. Finally, question number 5, explain the difference between regression and classification models. Regression models are helpful. We're trying to find a continuous value, so temperature, price, number of active users. Really just when you're looking for a specific value, saying this is on this day the average temperature is 97. That kind of thing. Classification models, on the other hand, make categorical predictions. So if you wanted to make a prediction about whether someone will buy sodas in the middle of July, that would be categorical because it'd be a yes or no answer, right? Buy or sell. If you're for financial projects, maybe it's fraudulent, not fraudulent, that sort of thing. Thank you for your time.